Now that you understand the basic structure of a periodic table in general, we're going to get specific with the families of elements. As a reminder, families are the vertical columns, and everything in those columns have similar, not identical, but similar properties. So what we're going to be discussing is why are these elements together in the same family. Throughout this video, I will be referring to the drawings on this sheet and the diagrams and the information that they have, and I will also be instructing you to color in parts of your periodic table. So make sure you have that out so you can color and label appropriately. The first family of elements that we're going to discuss are the alkali metals. Those alkali. They are, by far, the most reactive of the metals. The reason for that is that they have a valence number of 1. Now, the valence number is going to be the number of active electrons, the number of electrons that are either being given away or taken in by the atom. In the alkali metals, the atoms all want to give away 1 electron. This makes them very, very reactive. So reactive that they are never found by themselves in nature. They have already been reacted with something. On your sheet of diagrams, go ahead and find these 4. We have hydrogen, we have lithium, we have sodium, and we have potassium. And they are all located in the same column. The reason for that is they are all desperate to get rid of this 1 electron in their outer shell. Now, if you take a look at potassium actually has 9 electrons in its outer shell. But if 1 of those electrons were to be given away, then it would have 8, which, as we know, is a stable situation. On your periodic table, I want you to go ahead and color in this first column, and I want you to label it alkali metals. Up next we have the alkaline earth metals. It's alkaline earth metals, which are still very reactive. They want to give away 2 electrons, so their valence number is 2. They are not as reactive as the alkali metals were. And as far as metals go, they're pretty soft and pretty low in density. On your periodic table, go ahead and color in the second column and label it alkaline earth metals. The transition metals are not a vertical column family. It's a big family. Think of it like an extended family of more than 30 elements. And these I refer to as stereotypical metals. They're high in density, they're excellent conductors, they have high melting points. These are the metals that you know: copper, zinc, gold, silver, titanium, iron. These are metals that you think of when you think of the word metal. On your periodic tables, go ahead and color in the center section. These are the transition metals, and label it accordingly, please. The transition metals, your typical metals that behave the way you expect metals to behave. The next family is not very interesting, which I guess is why it's called the boron family. That never gets old. So, the boron family, the carbon family, the nitrogen family, and the oxygen family are all split families. Part of them are metals, parts of them are nonmetals. They each have their own valence number. Carbon family is an important one because they can form lots of different connections with lots of different things, which is why carbon and silicon are so important. And as a side note, the oxygen family with a valence number of 2 ends up being a good partner for a lot of things that are reacting. On your periodic table, go ahead and color in and label the boron family. Try not to fall asleep while you do it. It's boron. Anyway. And you can go ahead and color in and label the carbon family right here. And you can color in and label the nitrogen family right here. And you can color in and label the oxygen family. And now we're going to go back to our diagrams. I would like you to please find chlorine and fluorine on your diagrams and try and figure out what they have in common with each other. So if you took a look at those diagrams and you said, wow, it looks like both of those just want to get one more electron, you're right. Now, since their valence number is 1, they are extremely reactive, which is, of course, why we use things like chlorine and iodine to kill things, because they are very, very potent, very reactive substances. Just as reactive as the alkali metals were, but in the opposite way. They're trying to take an electron from something else. So on your periodic table, go ahead and color in and label the halogens, the most reactive of the nonmetals. Okay, now going back to our diagrams, I would like you to find these three. Helium, which is number 2, neon, which is number 10, and argon, which is number 18. Now I want you to take a careful look. Each one of these already has a stable situation, either full or 8, in their outer shell, which means they're not going to want to do anything, which is, of course, exactly what they do, or don't do, as the case may be. The noble gases are often called the inert gases because they have a valence number of 0. They're already stable, which means they don't do anything, which is why we use them for some of the things that we use them for. Welding or protecting old documents. They are not going to react with the things that we are working with. So on your periodic table, I would like you to go ahead and color in and label our last family, which is the noble gases. For those of you who are wondering, and there's bound to be somebody wondering, these elements down at the bottom here are called the rare earth elements. And they are grouped together because they all resemble each other and they're very difficult to separate. They're called rare earth elements, but they are not exceptionally rare in and of themselves. But they're grouped together because they tend to be similar.